Way 58 has to deal with formula writing and how you actually write the molecular formula given the name of a specific compound. The way you're going to do this is you're going to look on the periodic table and look up the oxidation state or the typical charge present or formed from those atoms. It's indicated by the top right corner number in the periodic table. Then you're going to crisscross those values, meaning you're going to take the charge of one atom, move it down to the subscript of the other, and do the same thing for the opposite atom. Then you're going to simplify that ratio if necessary. Please note that compounds that contain multiple oxidation states are differentiated by Roman numerals. So for example, if you look up copper, Cu, there are two oxidation states present, +1 and +2. To differentiate the two, we use a Roman numeral 1 for copper +1 and Roman numeral 2 for a charge of +2. And the same goes for atoms that have multiple oxidation states. The second element will frequently end in the suffix IDE, ide. So, for example, we won't say sodium fluorine, we'll say sodium fluoride. Please don't get confused by IDE ending. Ide simply means that we've changed the atom, the original atom somehow by forming some type of ion. When you are combining multiple atoms, typically you can get away with using the topmost oxidation number, especially for the nonmetals. So for example, chlorine, you'll see has multiple oxidation states. In general, the topmost number is the one that most frequently forms. So it'll be -1. What is the chemical formula of titanium 2 oxide? If you don't know the symbols for these elements, you can always rely on table S to find out their symbols. Then go to the periodic table and find out the oxidation states. The fact that titanium has a Roman numeral 2 written next to it means that the charge of titanium is +2 and the oxidation number of oxygen is -2. So we crisscross these values and we get Ti2O2. Now notice that this ratio can be simplified to form TiO. So the answer choice is 1. Next question asks, what is the chemical formula for sodium sulfate? Please note that if you encounter an atom or element that seems to not come directly from table S, it's most likely from table E, one of the polyatomic ions. And polyatomic ions are actually groups of ions that consist of a combination of elements that have somehow formed a charge. So here, sulfate is actually corresponding to, where is it? SO4, 2 negative. So when we write down the chemical formula for sodium sulfate, you're going to need to rely on table E, but the same rules apply regarding the crisscross rule. Looking up the oxidation numbers for sodium, you'll find that sodium forms a +1, sulfate has a -2, so the answer is 1. Because when we crisscross the values, the 2 moves down to sodium and the 1 moves down to SO4. So it's Na2SO4. Next question, what is the chemical formula for lead 4 oxide? Again, you recognize the Roman numeral, so you should immediately convert that to the oxidation number. When we write down the symbols, lead is Pb, oxide is O. Notice the IDE ending is referring to oxygen. Here we have Pb +4 because of the Roman numeral 4, and oxygen has a -2. So crisscross these values, we get Pb2O4. Then we have to simplify this ratio by taking the greatest common factor between these two and simplify it. So the simplest way we can write this is PbO2. So answer choice 1 is correct. The sample of seawater is analyzed. The table below gives the concentration of some ions in the sample: chloride, sodium, magnesium, sulfate, calcium, and potassium. Write a chemical formula of one compound formed by the combination of potassium ions with one of these ions as water completely evaporates from the seawater sample. For this problem, please note that it's not possible to combine two positive ions in a compound, so we're really just looking for what type of compounds we can form when we take potassium and combine it with any one of the negative ions listed. And the only way we can do that is by forming potassium chloride, which comes from K plus and Cl minus, or we could simply write potassium sulfate. And notice that in order to correctly write this formula, we apply the crisscross rule. The 2 moves down to K, and the positive 1 moves down to SO4. So there's simply 2 Ks and 1 SO4. So either one of these answers is correct. What is the chemical formula for zinc carbonate? Again, you have to rely on table E in order to correctly get this answer correct. Looking up the oxidation numbers for zinc, you get positive 2. Carbonate, which comes from table E, has a negative 2. So when you write down the formula, they each have positive 2, negative 2. Crisscross, note that the ratio can be simplified. We have 2 to 2, which can be simplified to 1 to 1. I don't need to write down the ones because zinc is already written, as is carbonate. So the formula is 1. So remember to apply the crisscross rule. First, look up the oxidation numbers of the constituent elements, or sometimes we have to rely on table E to refer to specific polyatomic ions. We write down the oxidation numbers for each element, then we crisscross the values and then simplify the ratio if at all possible by taking the greatest common factor present within those two subscripts. Once we do that, we can get our correct answer. Hopefully this was helpful, and thank you for watching.